Hey guys, this short video is going to take you through our third section of the conics chapter, which covers circles. So you talked about circles a lot in geometry, circumference, area, different theorems like tangent, tangent, secant, secant, chord, chord, all those kinds of stuff. So we're not really talking about that. We're more so talking about when your circle is on a coordinate plane, how to write the equation of it. So you're very familiar if I ask you the equation of a line in slope-intercept form. You could say y equals mx plus b pretty much in your sleep by this point. By the end of maybe even today, but at least for this chapter, I'm going to ask you the standard equation of a circle, and you're going to need to know that as quickly as slope-intercept form of a line. Of a circle, standard form is x minus h in parentheses squared plus y minus k in parentheses squared is equal to r squared. It looks slightly complicated, but the good news is hopefully you recognize the h and the k. Similar to the parabolas that we talked about last class, the h and the k in this instance, instead of standing, there's no vertex of a circle, but the h and the k represent the center of the circle. So the center is the most important part. It gives you the location of the circle. The other thing that defines a circle is how big it is, which is going to be the radius. So obviously, radius is equal to r. So that's it. You need two things to write the equation of a circle. You need the center point, and you need its radius. So I'm going to take you through 5 examples, some similar, some a little bit different, of the different scenarios that you could possibly get with a circle. Number 1, I want you to sketch a graph of a circle with the equation x minus 1 squared plus y plus 3 squared is equal to 4. So the first thing you're going to notice is that everything that I've given you is already in order. This equation looks exactly like the standard equation, but with actual numbers. The x and the y, obviously, you're going to stay x and y the entire time. But if I asked you for the vertex, you would look at your h and your k. Again, insiders lie because it's minus h and minus k. So the vertex in this case would be 1 comma negative 3. And then every equation of a circle is equal to r squared. So if 4 is equal to r squared, then that implies that r, you're going to take the square root of that, is equal to 2. So if you were to graph a circle with this, with these details, we would, you don't need graph paper on this case. On your homework, I've given you graphs that you get to use. But for now, I'm just worried about rough sketches. When you graph, you'll start with the center point. 1 comma negative 3, so 1 on the right, 3 down. Label that with C for your center. And then if your radius is 2, what you'll do is from the center point, it's kind of hard to do 2 in every direction, obviously, but you'll do 2 in the 4 main directions that you can actually count. You can count 2 up, 2 to the left, 2 down, and 2 to the right. And then you're going to do your absolute best to connect those 4 to make them look circular. It's okay if your circle looks more like an oval, aka an ellipse, or just some other weird thing. I really just care that those 5 points are in the correct location and that you made a decent effort to connect them. So that would be it. That's your circle with a vertex of 1, negative 3, and a radius of 2. Let's do another. Number 2, I want you to graph a circle that has the equation x squared plus y minus 4 squared is equal to 4. Similar setup as the last question. Everything's in order. Your x squared is first, your y squared is second, your constant, oh, I'm sorry, not 4. I want this to equal 10. And then your constant on the right-hand side is equal to 10. The only difference is that there is no x plus or minus a number, which means that your h value is actually just 0. So that means your vertex is going to be 0. Again, insiders lie, so if it's y minus 4, it's going to be positive 4. And then again, if r squared is equal to 10, then that implies that the radius is equal to the square root of 10. Now, obviously, you're not going to graph this perfectly because the square root of 10 is not a square number. You're just going to do your absolute best to estimate where this should be. So if it's at 0, 4, obviously I'm going to need more of my graph above the x-axis than below. So we'll graph that vertex. I keep putting V for vertex. It should be center on both of them. Hopefully you didn't get angry with me until now to see that. Sorry, center point is at 0, 4. So 1, 2, 3, 4 is your center point. And then if the radius is 10, obviously the square root of 9 is 3, which means the square root of 10 is a little bit more than 3. So from your center point, you'll just need to count up 1, 2, 3 and a little bit more, down 1, 2, 3 and a little bit more, and then the same thing left and right. And then connect those 4 points to make them look circular and call it a day. So the thing to know here is obviously it's ideal if the r squared ends up being a square number that you can take the square root of, but many times it might not be. That still doesn't change how you would approach the problem. Number 3, similar question. I want you to graph a circle that has the equation x squared plus y squared plus 6x minus 16 is equal to 0. So what you'll notice of this one compared to the others is how different the equation is. There's no sets of parentheses. In fact, you have more than one x term. You have an x squared term and you have an x term. So the first thing that you're going to do if you're given just a bunch of it seems like extra stuff is I want you to regroup. When you regroup, you're going to put your x's together plus your y's together, and you're going to set those equal to any constant that you may have. So if I were to regroup, I'm going to write it as x squared plus 6x, those are my x's, plus y squared, and then I'm going to move that negative 16 to the right-hand side to be a positive 16. So that's the regrouping aspect. And then I need to make this look like the standard equation of a circle. So again, if you remember, and I'll just rewrite it here for your reference, standard equation of a circle is x minus h squared plus y minus k squared is equal to r squared. So the y is okay, that just means k must be 0, it's y squared, but I've got to get these x's to be written as a binomial squared. So you're going to take the skills that we re-practiced last class about completing the square, and you're going to complete the square with your x values only. So if you do that, you're going to take your x's. Remember, when you complete the square, you want a leading coefficient of 1, which you have, right? There's no number in front of x squared. So you're going to do x squared plus 6x plus, you want to leave room for a new c to go with your x trinomials, plus leave y squared alone, leave 16 alone. As we already reviewed for the homework video, to find the new c, you're going to take b over 2. So that would be, in this case, 6 over 2 squared, which is 3 squared, which is 9. So if I add 9 here, think about what I just did. I added 9. There's nothing on the outside distributing to it, so it is a true 9. I added 9 to the left side of my equation. So you have two choices. You can subtract 9 from the same side so that it zeroes out, or if you add 9 to the left side, you can also add 9 to the right-hand side of your equation, and then it stays balanced. So then you can rewrite your trinomial of x's as x plus 3 squared. That's what this becomes. Plus y squared is equal to 16 plus 9 is 25. Now this looks just like the standard equation of a circle. So then if I ask you for the center points, again, insiders lie, so if it's x plus 3, the center is going to be negative 3. Y doesn't have a value tied to it, so it's just 0. And then if r squared is 25, then that means the radius is 5. So if I sketch this, again, you need more because the center point is 3 to the left. You'll need some more space to the left side. So 3 to the left will be here. That'll be your center point. Radius of 5, you'll count 1, 2, 3, 4, 5 to the right, 5 downward, 5 to the left, and then 5 up. So this one's going to be really pretty. This one looks more elliptical just because I didn't draw my tick marks on my axes correct. It'll be a little bit easier on your homework when I provide you with a graph and you don't have to sketch it yourself. So, moral of the story here, if I give you an equation and it's not written in standard form, you will probably complete the square in order to get it that way before you are able to get the center point and the radius and graph. Which leads me to number 4. Number 4, I don't want you to graph, I just want you to write in standard form. And I'm telling you that this is a circle. write in standard form. If I give you the equation 4x squared plus 4y squared minus 16x plus 24y minus 36 is equal to 0. So again, this one is all kinds of jumbled up. I have an x squared and an x term, a y squared and a y term, and it's set equal to 0. So you can do two things. You can start off by regrouping the way that we did on the last question, or you can start off by trying to simplify some of your numbers, recognizing that all of them are divisible by 4. So if you notice that all of them are divisible by 4, then you are allowed to divide every term by 4 and just kind of simplify your numbers a bit. So if I do that, then I am left with x squared plus y squared minus 4x plus 6y minus 9 is equal to 0. So it just kind of makes my numbers a little bit smaller. And then I can regroup. That would be x squared minus 4x plus y squared plus 6y. I'm going to move that negative 9 to the right-hand side to be a positive 9. So then you'll notice, different than the last problem, I have two x terms and two y terms, which means I'm going to complete the square twice. I'm going to complete the square with the x's and with the y's. So for the x's, again, I have no leading coefficient. I don't have to factor anything out. So that leaves me with x squared minus 4x plus room for a new c, plus my y squared. I don't have a leading coefficient there, so I don't have to factor anything out of that one either. Y squared plus 6y plus room for a new c is equal to 9. And then you'll complete the square twice. So for the x's, b over 2 will be negative 4 over 2 squared, which is negative 2 squared, which is 4. There's no number on the outside that I'm distributing to that 4, so it is a true 4. If I add 4 to the left side of my equal sign, to balance that out, I'm going to add 4 to the right side of my equal sign. And I'm also going to complete the square for the y's. b for the y's is 6, so 6 over 2 squared is 3, and 3 squared is 9. So if I add 9 to the left side of the equal sign, to balance it out, I need to add 9 to the right-hand side. So you complete the square twice, you end up adding two numbers to each side. Now you can rewrite your trinomials as binomial squares, and then that ends up being x minus 2 squared plus y plus 3 squared is equal to 9 plus 4 plus 9 ends up being 22. And that ends up being your final answer. This circle would have a center point of 2, negative 3 and a radius of the square root of 22. Okay, last problem, number 5. I want you to write an equation of a circle whose diameter, let me just give you that information, whose diameter has endpoints of 3, negative 3, and 1, 5. So what I want you to do is you just sketch what this would look like. It doesn't have to be perfect. But if it has endpoints of 3, negative 3, and 1, 5, that would be 1, 2, 3, negative 1, 2, 3, and then 1, 1, 2, 3, 4, 5, 5 like this. So if these are the endpoints of a diameter, the diameter connects, it will connect them, and then the most important feature of a diameter is that it goes through the center of the circle. So the center of the circle is somewhere in the middle. We can't trust that we graph this perfectly and just like count and estimate where that may be. We're going to have to do some calculations. So again, the circle is going to look something kind of like this. And we've got to figure out what is the center and what is the radius. So if you think about the relationship of the diameter and the center of the circle, then you would hopefully notice that the center is the midpoint of the diameter. I really hope all that coughing isn't too loud in this video, but sorry if it is. If the center is the midpoint of the diameter, you're going to use the midpoint formula we talked about last class. So you'll say capital M for midpoint is equal to, remember, the average of the x's and the average of your y's. So 3 plus 1 over 2, and negative 3 plus 5 over 2. So 3 plus 1 over 2 would be 4 over 2, which is 2. And negative 3 plus 5 is 2. 2 divided by 2 is 1. So there's the center. So midpoints, this is center, which also means this is our h and our k. The only other thing that you need to be able to write your equation is the radius. You can do this in a couple different ways. You can say, okay, I know the radius is half the length of the diameter, so you can find the length of the diameter and then divide it by 2. Or you can say, okay, I know the radius is the distance from the center to one of the endpoints. So if I say that the radius is distance from the center, which we've just discovered is 2, 1, and one of the endpoints, you can pick either one that you want. You'll still get the correct answer. I'm going to pick 1, 5, just because I like positive values. So then again, keyword here is distance. Take what we learned last class, say, okay, distance is equal to the square root of, open parentheses, x2 minus x1. So 1 minus 2 squared plus, open parentheses, 5 minus 1 squared. If I simplify that, that'll equal the square root of 1 minus 2 is negative 1 squared, plus 5 minus 1 is 4 squared, which is equal to negative 1 squared is 1, plus 4 squared is 16. 1 plus 16 gives you 17, so that means the radius is the square root of 17. If I were to write the equation of a circle, so again, let's recall, the standard form for the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. We know h and k was 2 and 1, so that would be x minus 2 squared plus y minus 1 squared is equal to r squared. Well, if r is the square root of 17, then you're going to take the square root of 17 and square it, which essentially is just going to cancel out the radical, and then you end up with x minus 2 squared plus y minus 1 squared is equal to 17 as the final equation for that circle. So that walked you through most of the types of scenarios that you could possibly deal with circles. Once you get your homework, and you can rewatch this part if you need to, once you get your homework for 10.3 on circles, question number 7 ends up asking you, or it tells you, okay, you have a circle with a center point at negative 6, 5, and it is tangent to the x-axis. If you think back to your geometry days and the meaning of something that is tangent, if a line is tangent to a circle, that means it intersects the circle exactly once. So tangent means intersects exactly once. Intersects exactly once. So if I were to draw this scenario, that would end up being a center point at negative 6, 5 would be here. If it's tangent to the x-axis, the x-axis is below, that means it's going to intersect the x-axis exactly once. So it will bounce here and then come up this way, and the rest of the circle will end up forming that way. So draw that scenario, and then it will excuse me, allow you to count the radius. So you're given the center, you just need to count the radius, and then you can proceed there. So hopefully the homework is pretty straightforward. Check your answers on Google Classroom, email, or stop by if you have any questions.